Hi everybody, good morning. I'm doing quick write-up for this room. Chaining vulnerabilities. Learn how to chain vulnerabilities from low to high. I think this is a free room. Free room. Anyone can do it. It was released yesterday. It's a good little lab because we have a lab for it here. We'll check it later on. I'm not doing the lab, but the idea is interesting. It's where is the so guys, you can read as I said. So when we talk about vulnerability chaining, we're referring to the idea that a single bug on its own might not seem like a big deal. So the argument is you'll find, for example, several low risk or medium, but each own doesn't do any damage. But when you combine them, that's how it works. Most of the fancy, even high impact ones, they chain things. Uh, this brings us to something important that often overlooked when reading pen test report. Risk rating are assigned per vulnerability in isolation. I didn't know this. Organization usually focus on remediation for the criticals and high, while deferring or accepting medium and lows. But this mindset can be misleading. A medium risk vulnerability like verbose error messages or weak password policy might not get immediate attention, but when chained together with other issues like missing CRF protection or XSS, it could lead to a much higher impact. So this room basically it teach you how to think like an attacker, learn how to trick even small finding as potential stepping stones, understand common chains. Some bugs naturally pair well together like XSS and CCRF, recognize weak boundaries, follow real chain. A prerequisite, yeah. So you can understand the code we'll use later on. Some CCRF. What they push in the this TryHackMe new one stuck in question. I didn't stuck yet. Chaining vulnerabilities. What is vulnerability chaining? Vulnerability chaining is when two or more individual weaknesses are combined to cause greater damage than they could alone. Think of it like this: one vulnerability gets your foot in the door, another gives you access to sensitive information. For example, let's look at a better example. Imagine you find a self-XSS vulnerability in user profile editor, like we'll see now in the lab. This kind where the payload only run in your own browser on its own, that's pretty limited. You can't use it together any target anyone else. But now imagine that the application also lacks CSRF protection. You craft a CSRF payload that forces an authenticated victim. This is well known in CTF, where another user or admin log in from the other side and then you steal their cookies or change their password. Is basically this lab now. So, and also sometimes it's another common scenario: an attacker find a page vulnerable to SQL injection, but it's behind the login. They also notice that the login form gives away where the username exists. So they use brute force, things like that. So they give you an example here. A self-exit profile editor use CCRF vulnerability present protection and forms. CSRF used to inject XSS. That's usually what we'll use as a payload. On your view profile, this is the classic CSF. Then you still attack again admin session or execute arbitrary GS or change the password. Uh, for example, a real word here, SSF vulnerability in WAF, access EC2 meta URL, extract aus IAM credential, use credential to list and download S3 bucket, massive data breach. Um, why patch by patch fix aren't enough? It's common for development team to fix vulnerability one at a time, treating them isolation. That's usually when you solve one, you need to go back and look to the bigger picture. So see if they affect each other, because sometimes you update one thing, it will affect other ones too. Everything is connected. The methodology, how to think like an attacker. As a skilled attacker rarely find a single vulnerability and immediate win. Instead, they explore the application like a curious user, identify small cracks and slowly build up a path of their objective. For example, use an application like a normal user. I heard this mini advice from attack bug bounty is always start this. Don't try to rush it or try to be fancy. In the first step is always before anything else. Explore the application with no assumption. Just look what the normal user do before you think like an attacker. Enumerate and find weaknesses. Now shift your focus and define weak spot. This might be classic vulnerability like SQL, XSS, or IDOR, or subtle behavior like inconsistent error messages. Use ID pattern in URL, and it's this room before this. I need to do it too related to IDOR. Step 3, understand what each finding enabled. For example, does the XSS run in useful context? Can the verbose login help with username enumeration? Will the file upload let me drop a script somewhere? Step 4, think like an attacker. What is the goal? Steal sensitive data, access admin panel, escalate to remote code execution. Context method access on the blog might annoying, but in a banking dashboard, that's a very different threat. Build path from weakness to objective. This is where you connect the dots, look at your list of vulnerabilities, and imagine a logical path from an external user to attack a goal. For example, verbose login, valid username, a get username, then weak password, cracking, get stored access, admin visit, access, fire, admin cookie, a privilege escalation. Execute and validate each step. Can brute force password because if there is a rate limiting or something, does your access trigger right context? Will the stolen cookie actually let you access admin dashboard? Report the full chain. When reported, don't isolate the bugs. Tell the full story. Okay. Also be clear about impact escalation. While each individual issue might be low or medium risk, together this result in full compromise of the system. Now let's go to our application. Now in application, of course, the first thing you do when approaching any login form is to try to easy stuff. In this case, the web application hosted in this IP has tested count left behind from the developer. So basically his assumption is we found either by brute forcing or something, we find like test user password 123. That's the assumption we have here in this room. It's uncommon. Dev often leave test data in place during staging. It's make way into production. So the assumption is we found a test user, so we have that. So of course, whenever you do, I always like to have this habit of check the network. Then we have password 123. Of course, you log in. And then you can see here it is nothing special. There's a dashboard, there's a login. If you go to admin, it will ask me for the password, so that's cool. Edit profile, we have that one. I can change the password. Okay. You go dashboard. Of course, when you see this thing, it say my test. If I do update, it reflect back, or even it is reflect like that. So either ginger things like that, but it's reflecting XSS things like that. Here, you can start with your classic. For example, script alert hi. No, sorry, hi. And then you update, and you can see it's pop up. Now we got one thing, so we have already we have the first so we know there is an XSS, so you can say okay, I got my finding. Let's go up before. This is the code we'll use now. So the first thing I have an XSS, so I confirm there is XSS. The next thing, of course, you go to the app. For example, if I click update mail, I can change the password. So my password was password123. So if I do password, uh, can I, of course, let's say I have a verb already on to confirm something. So if I get that, I'm trying to change my password. I'm not changing it, but let's see what exactly happened. Send to repeater, repeater, go there. So this is the repeater. So if I take the username, I take take the email and take the new password. But if you look at the header here, we have the cookie there. So that's fine. So that's our cookie. So we can know it's a cookie because we have it in the storage. So we have our session there, but the missing is we don't see anything is usually if there's a protection, for example, if it's a CSRF token or something equals something, but we don't see this, so we don't have this, we don't have the protection. So basically the password get changed only by the cookie. So the only thing needed is the cookie, and that's the key here uh, in this room, because there is no protection that who sent this request. The only thing is the session. As long as the session is there, it will send. Doesn't tell you who sent it. And that's what the example here. Here, of course, we have the alert, and this is where the attacker mindset kick in. The vulnerability is clear, but how can we use it to escalate? We know that an admin might view this profile, perhaps as part of moderation flow. So, so now CSRF via access changing admin credential. Let's pause and be clear. With stored access like this, you could achieve a account takeover entirely using JavaScript alone. You might read DOM content, extract CSRF token, and craft a legitimate request. In our case, application doesn't implement CSRF token at all. That makes things simpler. When you access a file in the admin browser, you can just send the same origin post request to change the admin email and password, and the browser will attach the cookie automatic. So because we don't have CCRF protection, so the idea is we can use this. For example, we can use this script. This script basically send a post request to update email. This is exactly what happened. It will do this for us. So we just use the admin cookie here and just send it and change the password for the admin. So now if you follow the room, you can just do view, zoom in. So we can just see in script.js, so vim script.js. So we changing the email and we changing the password. Let's leave that there. We do that. And we can just run our Python server to call the Python http.server. So basically and then we can just call because we know there is an XSS, so we can use that to our advantage and call this script.js. So when the admin login, the JavaScript will send the post request and change, basically doing this for us. So now if I go to update profile, we test it. I can just remove that and update. Now if the admin login now you can see it's automatic. The admin came and downloaded the script, Let me cancel this. I don't want it to keep running in that one. Sorry. So if things get well, if I go to dashboard, if I log out, if because it's download, the script already changed, so the assumption is to have this email. That's my new email for the admin, and we have this password. Now let's see if now we are able. So if I click admin, what's good? The password didn't change yet. Password. What happened? That's interesting. What I'm doing wrong? Oh, username is not. So the assumption we know it's an admin username. Hmm. So he's not logging with the user. Sorry. Let's. I was confused. So the assumption is username is admin. Why is not? What, my CCRF didn't work? What the hell? Yeah. The script.js. Where is the script.js? Pawn admin. What am copying me? You suppose username or admin, so it should work both of them. Doesn't work. Wait, is there someone else working in this room? It came, so in theory it should work. And the computer is freezing. What's going on here? Why when you make a live video, when you make a video always, and the room is freezing some. Sometimes TryHackMe, the servers are. The machine is freezing. Don't tell me you need to start the machine now. Damn it. Now he's logging. But why it took long? I'm very strange about it. It's freezing, you can see it. I'm not able to. Sometimes TryHackMe infrastructure becoming problematic in general. Not sure, too much free. When it's free rooms, they freeze them. Let's try something else. Let's log out. Admin, display administrator, pawn admin. Uh, I want to try some. Yay, my goodness, TryHackMe. What's wrong with you? Now let's let's finish this and then we come back to that one. What vulnerability enabled the attacker to force a change in the admin user? Yeah, it was an XSS. We use XSS most of the time. The CSRF was only to for the payload, downloading it. So cross, what do I call it? Cross site scripting. No, here's the idea is because here suppose the application did have CCRF token in place and you attempt to change the admin email silently failed. Does this make accessor useless? Far from it. A creator wouldn't give up. They think about what else accessor could do and cut admin session cookie. So let's try for example to get the session. So now we can steal the session. What was that test user? Uh, Test user password 123. This is our password. Did we change it? For the sake of Lord, what's going on in this room? Test user password 123. We didn't change the password and didn't submit a request. Test user password 123. What is going on in this room, to be honest? I didn't change the password for the test user. Test user password 123. TryHackMe. Hmm. Does the password? Let's close this. It can be changed our own password. Yeah, it does make sense because the accesses is also in our profile. When we refresh, we log in the page, we change also our own password. So own password changed into this because it's also in my profile. Okay. I'm not admin, so that's fine. So the idea now, let's edit. Stop calling this script. I'm not. Let's call script two. Um, let me change the port minus m minus p 9000. Oh, not p. Let's change it in 9000 and let's vim script 2. Let's use this one. Here we are still in the cookie. Not 8000. Send it to 9000. So, so basically, we want this time to take the cookie in case there's a CSRF. So to 9000. That's my IP. Let's see update. What the hell happened? He's redirecting something. I can see the what exactly he's doing here. I think I did mistake. The cookie is not there. There's a cookie here, but which cookie is this? What's the IP? 228.219. That password that we changed. Test user. I'm still user. I'm still user, but I don't know what something is it redirect without even give me a chance. I think I did something wrong. Which script I test yesterday? Any case, I don't know what's going wrong. I'm having headaches. This is I think is my cookie. Uh, I did tried it yesterday and to work fine. I don't know what's going on now. So this is C7 is mine. So which one I'm getting here? Yeah, that's my cookie. I did test it yesterday. I don't know. Guys, let me pause quickly. I need to restart the machine. I think I did something wrong. Hi everybody, I'm back. Sorry, I restarted the machine. I'm getting new IP 10.10.177.187. That one, I think I use a wrong payload. So 177. No, so we log in as the normal user, the first one, the test user. Password 123, and of course we log in. We don't have access to the admin panel. The idea now is we can use that one to let's go back because I was testing it that it work here, so I know it's working. That's my previous test, but I restart the machine now. The script will use this one 9000. We'll use this one. This is the script 2. The idea is to steal the cookie. I was redirecting before, so I'm using port 8000, so we should see it here. Let's cancel this, let's clear, so we know is that. So I'm using now the image tag. The idea is to call this script. Where is that script? Do the image, then send me the cookie, and hopefully the admin will get the admin cookie, so we can test that. I'm using script 2, not script 1. The script 2 is the one that used the cookies, so I'm using this one. This is script 2. So now we're not updating the password. Okay, we got that. let's go to our cookie so we don't mix the cookie. This our cookie start with TU1. So TU1 is my cookie, is not the admin cookie. Let's make sure. Okay, we got something. TU1 is my cookie, but this one is not my cookie. The 9K2, this is not my cookie. We can go to dashboard. Admin panel, I don't have access to it, so if I change the cookie, refresh the page, you're kidding me. Oh no, it's working. So now we got we able to steal the cookie. So that's the admin cookie. You can see it's not the same. The T1 is my cookie. Where's the T1? The T1 is my cookie. The admin cookie is the K2114. So this is one way to steal the cookie. Hey, sorry guys, I was just confused now. So the alternative path, as I said here, in case you have a CSRF, you can try stealing the cookie like we did now. So that's the store access in profile, triggers you have to change admin email password, attacker log is not the admin, or fullback try boot force admin, CSRF token, steal cookie admin session, and things like that. And this is of course red team vs bug bounty different end game. Red team engagement primary goal demonstrate real world impact, identify gaps in the organization security posture. Bug bounty community risk clearly to the vendor. Chaining use pivot to escalate and achieve access used to show how multiple bugs combine. Execution style stealthy often avoid detection. Transparent design to be reproducible. Yeah, that's because that's how bug bounty usually. And objective level of frustration for chain. Partial exploitation is fine if risk is clear, so you don't need to get full blown on it. POC quality may use real tools or simulate ops activity, require clean, minimum, and safe reproduction. Yeah, that's this room is, yeah, it teach you the idea of thinking. By now you've seen the first hand how vulnerability that might seem low risk and their own can combine to cause serious damage. The key lesson from this walkthrough isn't just what default password and XSS or missing CRF token are problems. It's that together they can lead all the way from low privilege account to full system compromise. Yeah, maybe this Friday we'll have a room that do these things. I'm not sure. Sometimes TryHackMe they follow the rooms with that. Sorry guys for this messed up here. So yeah, thank you very much and have a good day.